Thanks very much. Thank you for the introduction. Hello and welcome. Thank you for coming and for listening to our talk. We've had the introduction a little bit already, but we're titling it Changing the Future of Asset Performance Management, Vibration Measurement and IoT. And we're here to talk about a Shell case study. I don't have a clicker. Should have thought about that earlier. This is my colleague Sophie Winter, former rotating engineer at Shell Panis, who's now just recently moved on to a new role as digital change lead at Shell, working with the global team. And I am Nadine Herrwerth, Managing Director at TWTG. We're an industrial IoT house developing our own IoT hardware and the corresponding software for complex data analysis. Today, we want to talk about the challenges that the industry, and not only Shell, but a lot of other companies in this industry are seeing. Then Sophie will discuss the specific Shell situation. We've got a short video prepared for you as well, talking about the implementation work there. We'll talk about how data analysis can bring change for the better. And then also we want to quickly touch on the ways of working of our two very different organizations and how we sort of made this happen. At the end, and hopefully during the Q&A, if there's such a thing, we will have time to delve a little deeper into how the TWTG solution is improving the day-to-day work of Shell's engineers. The challenges of these, not only the tank terminals or refineries, but all those companies in this industry are very similar. It's about having knowledge, having information, having precise data at your fingertips and being able to make decisions. It's about knowing whether machinery is running as it should be. It's about knowing whether the temperature of your machinery exceeds the temperatures that we want to see. And it's about knowing whether your rotating equipment is running on the right vibration frequency. Because not knowing can have detrimental results. It can be have results on safety. It can have results on your economies of scale. It can result, the bottom line of your sites, and that's what we don't want to do. And that's why the digital twin is so at the heart of our aspirations. And I just quickly want to talk about a digital twin as well. The concept is merely 12 years old, and it results at companies such as NASA. But it's not only those high-tech or extremely modern environments where the digital twin or having data analysis available as a decision support system is highly desirable. It's extremely difficult at large-scale and older organizations, and maybe also a site as Panis, which was started to be built in the early 1900s. But it's there where having this information, having the data analysis can make all the difference. This is where we can make sites smart, and this is where we can retrofit ATEX certified devices especially to allow us to gather this insight, because here is where we currently have a lack of knowledge and only a small amount of the assets are actually being surveyed. And being able with those retrofitting sensors to have your finger on the pulse and being able to see what is happening and taking a snapshot of your organization and of your assets will bring great change. I want to quickly highlight the neon vibration sensor, which is at the heart of the Shell case study. It's a wireless device that's communicating on LoRaWAN, and it's had a battery lifetime of up to 10 years. The extended frequency range of starting from 5 hertz to 6.6 kilohertz makes it extremely suitable for a number of different applications and a number of different use cases therefore as well. And it's the only device, the only LoRaWAN-based device with an ATEX Zone 1 certification that can actually provide the full spectrum analysis. And this is what made a big difference and is actually being implemented at Shell to decrease downtime and increase the safety of operators at Shell.
Thank you. So the sensor that you just saw, we as Shell have ordered 2,500 sensors, and we are currently putting all the sensors on the equipment. And as you can imagine, maybe if you have some experience on a bigger site, it's not that easy to implement 2,500 new sensors by putting them on the equipment. There are a lot of barriers to the implementation, both technically but also regarding people management. And well, together with one of the team leads, Leo van Driel, he's also over here, I discussed when we started the implementation phase, how and what questions are we probably getting from the field. And you can see we listed a couple of questions. For example, are these sensors ATEX certified? Why do we need more data? We have so much data already. Who is going to maintain these sensors? Who is going to replace the batteries? They were all afraid that they had to do it, of course. But yeah, before I go ahead and how we in the end convinced everybody that we should install these sensors, I would like to show you a quick video of both Leo and Pieter Verhaag. He's also over here, the two team leads of the rotating equipment team in Pernis.
We plan to build a new facility, the Handheld project, which aims to produce biofuels in the not so distant future. Part of that project also involves rotating equipment, and in addition to the existing facilities, we will equip this project right from the start with a significant amount of wireless vibration sensors. And right from the moment of startup and commissioning, we expect to gain a lot of information about the vibration behavior of our pumps in particular, which will significantly help us in understanding any deviations from that ideal behavior in the future. Much more than we can today with the only once in a month momentary inspections that we are currently used to.
In Pernis, we started looking at installing vibration sensors a couple of years ago. We have tested various sensors and piloted various systems. The TWTG sensors came out best, considering design and measuring accuracy. Our engineers had the opportunity to input our requirements during the design phase and co-develop the vibration sensors. In Pernis, we are now installing 2,500 sensors on our pumps, changing the way we're working. So from measuring once per month to on-demand measuring based on automatic daily monitoring. So far we are very excited and we are planning on the next batch.
Okay, well, that was a quick video explaining how indeed team leads think about the implementation and their view on it. But to convince the people in the field, we had to compare the current method, which is a handheld vibration tool, with the new sensor that we got from TWTG. And well, what we did was we took at a couple of time slots a measurement with the handheld tool at the position of the vibration sensor. And we just showed everybody in the field that was interested in it and had to work with it that the difference is is minimal. It's an accurate sensor. It's not always above or below what the handheld sensor measures. It's within tens up to maybe even hundreds of millimeters per second. So that helped. If we can go to the next slide, because apart from the people in the field, we of course always have to also have a business model behind this. We can buy a couple of thousands of sensors, but to be able to provide benefits to the business, we have to explain why we need the sensors. Well, of course, the sensors help us, especially on a bigger site like Pernis, to see have a better overview of the equipment health. We have over 4,000 pumps/compressors already in Pernis, and we are enabled to check all pumps, all compressors every day or every minute of the day. So with these sensors, we can make a dashboard and we can see instantly where we should focus on and where we have to act proactively instead of reactively. So currently, for example, if vibrations go up and people will notice, it's actually already too late, and we can only maybe help a little bit, but we cannot save the bearing, for example, of the pump or compressor. And on top of that, you can now also have a trend from every couple of hours, and you can look in historical data, and you see what might have happened what might happen in the future is already took place a couple of years ago, for example. And as soon as the trend goes up or shows a similar behavior, you can just say, well, we need to stop the pump now and do preventive maintenance before it goes like completely wrong, and we have to do a lot of repair work. Yeah, here's another application. So we have talked about the millimeters per second, just general vibration, but this sensor is also able to provide a frequency plot, as you can see over here. The application is called Solid Red and is made by TWTG. And we try to help develop it a bit. But what you can see over here is just an example of the application. So you see the acceleration spectrum, a before and after maintenance spectrum, and especially the high frequency range is now way lower after lubricating the pump. So that's a nice example of how it works.
Thank you so much, Sophie. Yeah, you just said it. You helped us develop it to a degree, and I think it was also in the video. If we're looking at the ways of working between our very different organizations, it was amazing because both sides brought their complementary capabilities to the table, so to say, and I believe that we've been able to create something that's really quite fabulous. We're quite proud of the device, of course, but the fact that Sophie and her colleagues are using it is even better than us being proud of something. So TWTG was able to bring fast and agile development, whilst Shell brought the thoroughness of the corporate structure, and it brought the overall, the global approach to this development. TWTG, we brought our in-depth and very deep tech experience of LoRaWAN wireless sensors as well. And on Shell side, the engineers have been fundamental, like I already said, fundamental in the capabilities of the device as it currently stands. And also this international approach has been invaluable for us. So now what we're doing with the software that we've just shown you a glimpse of, and we can talk a little bit more later on in the Q&As potentially if we have time, we're now paving the way for this international rollout to other Shell sites worldwide. All the sites are looking to Pernis as the front runner. And Pernis is providing the lessons learned, and very grateful for the team as well, so that all the other sites can roll it out in a very smooth manner. Yeah, we're very happy to take any Q&As, if we're allowed to take Q&As at this moment. Do I go and see the lady with the microphone?
Lily Chen from Dynamic International. So my question is, from the design stage and implementation of 2,500 sensors, what's the time frame you've delivered? Thank you.
Nadine, you can.
Thank you. Yeah, I can start. Do we have a
This
second?
one is working as well. Okay. You can use this.
For those who were here 2 years ago at the event, we did a pre-launch, so that is therefore 2 years ago, of the device. We delivered it, the first devices were delivered to Shell in April probably last year, so development timescales is a year roughly. We've got a lot of underlying knowledge and experience in developing ATEX certified devices, and we've got a lot of experience in terms of LoRaWAN as well. That's why we can do it within a year. But then, of course, there's a lot of testing involved at a later stage, and that big rollout is now starting. So that's an extra year on top of it. There's another question over there.
Yeah, Branislav Winter, MOL Group, Oil and Gas. One question to you, Nadine. How are the LoRa signals from the devices captured? Do you use some antennas or public?
Yeah, so it needs a complete infrastructure, which Shell has set up themselves. In other cases, like Fopak, they're sitting here in the front row. We're setting up the LoRa network for the customer, but you've got the devices. They communicate with gateways, which are around the site, and then it's normally power over Ethernet into the LoRa network server, we're agnostic, so it doesn't matter for us which LoRa networks that we were working with, but we can also provide the full end-to-end solution.
Excellent, thank you. And then the second one to Sophie. What was the answer to the rotating engineers? With more data, will they work more as well?
At the moment, yes, but in the future, not. So, no, we are creating a solution, and also with the application that has been provided by TWTG and our own tools, we we'll in the end have less work to do, because we don't have to go out in the field physically, and we can see on one dashboard instantly what pump needs attention and what pump is running.
Excellent, thank you. So it requires a little bit of change management too. All
Definitely.
Right. Thank you.
Thanks.
Yeah, thank you. Fulco van Geuns, Volpak. Just a question, Sophie. Are you foreseeing the need for DCS integration of the vibration things in future or not at all?
Well, currently the vibration sensors are only for monitoring, so not for controlling. And yeah, of course, on a site like Pernis, we have certain regulations on wireless sensors and the controlling mechanism of it. So I'm not sure how that is organized right now, but if you are interested into more detail on that, I would like to ask you to come to the stand and maybe ask the two experienced engineers as well.
Yeah, name is Pieter Vraag. I was in the video. To answer your question, I think for the moment the sensor will be purely for monitoring, and I think it will stay so in the future as well.